So if we look at this circuit, there are 4 independent loops in this circuit. So if we want to solve it as using loop current or mesh current method, we will end up having 4 simultaneous equations with 4 unknowns, and solving that is not easy manually. So if we make an observation, there are how many nodes are in this circuit. Nodes are there in this circuit. A node is a point where more than 2 branches are connected or 2 elements are connected. So this one is a node here because here R1, R3 and R2 are connected. Similarly, this is another node, 3 branches are connected. This is another node, and then there is a big node which is this one. This is the node. So there are 4 nodes. Now we will try to solve it using node voltage method. I will talk about that now. So this one, in node voltage method, we assign the node where most of the elements are connected as ground node or the reference node. So this is ground, and we try to write KCL equations for each of the other nodes. So KCL here, KCL here, KCL here, everywhere. So let's call it node 1, node 2 and node 3. So this one has a V1, this one's voltage is V2, this one's voltage is V3. We assign unknown voltages to each of the nodes, and those are the voltages that we want to find out to solve that. So here, if we want to write the KCL equation, let's assign all the currents as outgoing currents. So V1 minus E, because this is a voltage, over R1 is the current in through R1 branch that's going away from V1. Similarly, plus V1 over R2 is the current. Since this is a 0, so it's actually V1 minus 0 because ground voltage is 0. So we can just write the V1 because 0 doesn't matter. So that's the current through R2. And then this current, which should be V1 minus V2 over R3. See, all outgoing currents, sum is 0. So sum of all currents are 0, sum ingoing and outgoing. We are assuming all the currents are outgoing for each of the nodes. So this one I can rewrite like this. So V1 will be 1 over R1 plus 1 over R2 plus 1 over R3, then minus V2 over R3, and this one is equal to E over R1 that I can take on the right hand side. So this is the equation here. So this is the KCL equation for node 1. Similarly for node 2, I can write here. Again I should assume the current going away because that will give me a standard equation. So here again it is V2 minus V1 now because I am assuming that the current is going away from V2, plus V2 minus 0 over R4 because that's the ground, but I am not writing the 0 anymore, plus V2 minus V3 over R5. This one is 0. Similarly, if I again rearrange, it will become minus V1 over R3 plus V2 over 1 plus 1 over R3 plus 1 over R4 plus 1 over R5 minus V3 over R5. So that's the other equation I have, the second equation. Now looking at the third equation, I will just erase this part again. The third node, which is node 3. So that will become V3, again away, current are going away from that. So this one and this one. V3 minus V2 over R5 plus V3 minus 0 over R6, or just V3 over R6, plus V3, this one actually over R7 plus R8 I can write, or if I just assume, for simplicity, if I assume there is no resistance here, so it will be just R7. But if there was another resistance, it would be just V3 minus R7 plus R8, because it's the same current that's passing through R7 and R8, the same current that's going this way. So yeah. So if I rewrite this one, it will become again minus P2 over R5 plus P3 over 1 plus R5 plus 1 plus R6 plus 1 plus R7 is equal to 0. So we can see a pattern here again. For each of the equations there are three unknowns, V1, V2 and V3, and for the first one, if I look at this one, the node voltage here and all the elements that is connected to this node is coming as a 1 over, like in the loop current method it was just the element itself, they were added, but here the inverse of the elements are added, and then the node that it is connected to, the other node, that is coming as a negative, so V2 over R3, and this one is the current, that is the source over R1. Similarly for node 2, since this is a node 2, so this one is V2, and these are the nodes that are these are the elements that are connected to that node, and these are the elements that is connected with that the connected between that node and the other node. So V2 is connected with V1 as well and V3 as well, with two elements R3 and R5. So R3 is coming as a negative V1 over R3, and R5 is coming as a negative inverse of R5 is coming as a negative inverse. So that's how it is. So we can see a pattern there. Similarly for V3 as well, it's the same case. V3 is V3 over R5, which is coming here, V3 over R6 and V3 over R7, they are all added, and this the adjacent node is V2, so V2 over R5, because R5 is the element that is connected between V3 and V2. That's how it is. So what I will do is I will do an example then, and then we can have that determinant form, and then we can solve the unknowns just as the loop current method or mesh current method. So I will do an example example video later, just to illustrate how it can be done.